remember that we have recordings if you need to go online. Excuse me. All right, so section 4 is complex numbers. So the definition of a complex number. If a and b are real numbers, the number a plus bi is a complex number. So we get the idea of I. Now, do you don't remember what you remember what I is, right?
Mm-hmm.
What's I?
Square root of -1.
Okay. Because, and we call that the imaginary unit, right? Because it's not real. If I came up with something like this, and actually I think your book does that already. I'll give you an example. X squared plus 1. So there's no things that you could factor out to make that work without imaginary numbers, right? If it equals 0. You can't solve that algebraically. X squared plus 1 equals 0. X squared can't equal -1, right? Right? Without an imaginary number. So that's why we've defined the imaginary number as the square root of -1, which we call I. All right? It's just the imaginary unit. And so that's why we do it, so that when we're factoring, what happened was ancient mathematicians got into this and realized there's no solution. There's no real number that will satisfy that. So to solve the problem, they came up with this imaginary system. So you have an imaginary unit called the square root of -1. All right. And so if we write it like this, a plus bi, that's considered in standard form. Okay? They want the real number first, the real part first, and then the imaginary part second. Okay? And when you add a real number and imaginary number together, you get what's called a complex number. Okay? And so if b doesn't equal 0, the number a plus bi is a real number. Okay? If b does equal 0, the number a plus bi is an imaginary number. The number of the form bi where b doesn't equal 0 is called a pure imaginary number. So, in other words, if you just have an I part, 3i, that's a pure imaginary number. That's all they're saying. And if you have 1 plus 3i, then you have a complex number in standard form. Okay? Equality.
Oh, I remember this.
Outstanding. The quality of complex numbers. Two complex numbers, a plus bi and c plus di, written in standard form, are equal to each other. If and only if a is equal to c and b is equal to d. So if a and c are equal and b and d are equal, then those statements are equal. I is equal to I. Okay, it's just a standard constant. I is always the square root of -1. All right, so let's write some of these complex numbers in standard form, because that's, and I try to do these the way the directions read in the homework. So for example, if we write the complex number in standard form, how are we going to do that, Kelly, for this first one here? 3 plus the square root of -9. So if I want it in standard form, I want it in the form a plus bi.
So it's 3 plus 9. Or 3. I'm sorry.
Because that negative is the square root of 9
Yeah.
times the square root of -1, right?
Yep.
This is I. This is 3. Okay.
Oh.
Does that make sense to you, Ben?
Yeah.
All right. So you're going to tell me then, we're going to put this one into standard form.
Oh my.
That's not bad. What is it?
3 plus I.
My pen. You have -3. What is I?
Root -1.
Square root of -1. That's squared. Square root of -1 plus I. Well, now what? What's the square root of -1 times the square root of -1?
Negative. Positive 1. Negative 1.
You gave me 6 answers. What is
Negative
it?
1.
Are you sure?
No.
If you multiply 2 squares, the square root just goes away. It's just -1 times -1, which is 1.
Oh, 1.
-1.
What? You just said.
If you're multiplying these two things, the square roots go away. It's just negative 1 left, right?
Yes.
Okay.
Negative 1 has negative
Times
1.
times negative.
What?
Huh?
Negative times negative is positive.
All right. What's this? Pretend there's not a negative 1 in there. Pretend there was a 3. What would the answer be?
3.
It's whatever's in the radical, right? In the radicand,
Yeah.
right?
Yeah. What did I do
So
wrong?
then you have two
It's
negative
negative
ones,
1.
and you're multiplying negative
Wait.
1 by negative 1, which is positive 1.
No.
All right.
Is it not? What?
No.
No. The square root of negative 1 times the square root of negative 1 is the square root of negative 1 squared, right? Anything times itself is a squared, right?
Yeah. Oh,
So that's the same as
when
this,
you
right?
write it like that, it makes me think that you're squaring both of the roots, which made me really confused. Just forget what I
It's just
said.
negative 1, right?
Oh.
Well, you can't go any further if you understand. Does that make sense?
Then what is it? The answer is
I'm
3
not-
plus I, right?
Well, what's minus 3 minus minus 1?
Wait, what? Isn't it
Now you're
multiplied?
adding.
It's multiplied.
Minus 3 plus
Oh,
1.
for goodness sakes.
What?
I'm just erasing this part so that I explain, so it don't get, because you'll get confused if 5 things are written there.
It looks like it's multiplied, though.
Oh, for goodness sakes.
Oh, for goodness sakes. It's not multiplied.
What's that?
It's not. Well, how's it mine?
Okay,
I don't
you
care.
distribute that negative so that it's minus 3 plus 1.
Oh, I see what you're saying.
Plus
I put an extra negative there.
Yeah.
Oh,
Ugh.
sorry. Okay. So so you gotta give me the final answer here, Ben.
Negative 4 plus 1.
Whoa, whoa, whoa.
3
Negative.
plus 1. Something. I don't want to do math.
Sit up and look at this. It's negative 3 times negative 1. This is fifth grade.
It's 3 then.
That's all. Okay.
I said that. Did I not say? I'm
I
watching this.
don't remember.
3 plus what?
I'm so
I.
lost.
I said that.
What is just, if I have just I squared, what's that going to equal to?
Negative 1.
1.
So if just think of a negative 1 up there. It's just going to be the opposite of 3, which is 3.
I'm watching this math. I swear I said that. I swear.
I didn't say you didn't, but the problem is you say like 6 answers and you put your head down, so I don't know if you're just picking every number and hoping you hit on one. You know? Have you ever heard of bullseye math?
But it's just, I knew
The
it.
guy,
and then
the guy walks into a restaurant, and all over the restaurant, there's these bullseyes and a bullet in the middle of it. And so the guy in the restaurant says, "Wow, who's the good shot? Who does that?" He goes, "Watch, I can do it every time." He shoots the thing, and he goes and draws a bullseye around it. I mean,
But I said it, and
you can't say 7 numbers
you
and
need to
then.
be confident if I give an answer that's right, though.
All right.
'Cause if I give it.
Addition and subtraction of complex numbers. If a plus bi and c plus di are 2 complex numbers written in standard form, their sum and difference are defined as follows. So for the sum, you're just going to add the real parts. If you're adding, you add the real parts, and then you add
Oh, I remember this.
the imaginary parts, and that's how you get your answer. When you're doing your difference, when you're subtracting them, remember you're going to subtract your real numbers. I'll put a subtraction sign there. And then you're going to subtract your imaginary coefficients there, and then add the whole thing. So let's do a few. Because when you get C's and D's, you guys don't really know. That's hard to. So let's actually multiply some of these things.
Yes.
All right. Perform the addition and subtraction and write the result in standard form. All right, Ben, you can come up and do it.
Oh, no.
Yeah, come up and you do the first one. Oh,
Wait, is the answer that right for the first
that one up there?
one? Yeah.
I didn't write it down. I was going to do
Oh,
it.
darn.
11 minus 3 would be 8. So it's 8 plus 4i.
See, I'm
Almost.
not pulling. I'm not pulling these out of a hat. I know.
We'll finish. No,
Yeah,
redo the
I got
homework from
that.
last night that you guys didn't try. Do the ones you didn't try. Make sure, and then fill in the rest of your sheets. And also read the directions. So you don't have to do the homework for this, but if you fill in the directions,